Okay, so our session for today will be the last topic for algebra, wherein we will be focusing on the concepts of polynomials and the concepts of the graphs of certain nga mga equations like sari-sari yung mga polynomials at the same time concepts of rational equations kung paano natin mas medyo mapahapos ang ah, tanaw sa mga graphs nila, especially this one will be helpful sa mga higher mathematics, especially calculus and differential equations later on. So, this concept will be greatly helpful kag essential gid sa mga next ninyong mga subjects. So, since medyo small group na lang ta, do not be shy mag-ask mga questions or mamangkot kung may mga concerns ka mo or to clarify things. So, let's start the discussion. Okay, so our area of focus or our concern now is on polynomial functions. So we were able to discuss the concepts of algebraic functions in our previous discussion, in our previous session, and our focus now is on polynomial functions. So how do we identify if a certain function is a polynomial? Okay, again, how do we identify if a certain function is a polynomial in its certain form? So we have here a specific function which tells us that this is a polynomial function. We are given here function of x is equals to a sub n, x raised to n, and so on. So we have here starting sa n and then nigamatamat no buang aton nga exponents asa paglambot kita sa last part nga wala na kita exponent but this is constant na lang. Wherein take note all of the coefficients. So maghambak kita coefficients liwat balikan naton sa first concept sa ato yung discuss sa first session. All the coefficients are real numbers. So silingon tanan-tanan diri nga number before sa ato yung variable will be real numbers. So and take note, maghambal kita polynomial functions, the exponent must be non-negative integer. So, silingon, dapat tandaan natin yung exponents will be positive. So remember, integers are negative nga mga values including 0 and all positive numbers. So wala kita mag-consider dari nga decimals, wala man sang fraction. So, magkambal tanan negative integers, it includes halin sa 0, pakadto sa positive numbers. So, that is, amo lang na dapat ang exponent naton sa aton nga polynomial function. So, if you would like to know the degree of a certain polynomial, so that is the largest power on any x term on the polynomial. So, tanawon mo lang sa imong mga function. For example, kung may given ka certain equation, tanawon lang natin kung diin da ang pinakataas natin nga exponent, and that is the power sa ating nga polynomial. Okay, so I have here sari-sari ang mga polynomial functions. Ang kinanglan natin himuon is to identify kung ano ni kung polynomial siya or hindi. We have to classify if this one is a polynomial and if polynomial siya, ano siya nga degree. So help me with this one. So pwede gid maka-open sang mic in order for us to para mag-answer sini. So we have okay, we are given here function of x is equals 2x to the fourth minus x. Okay, so ang question sa buong polynomial niya or hindi? Anybody? Okay? Hindi mahuya mag-share. So anybody that polynomial or hindi?
Hindi, sir.
Nga hindi polynomial.
May duwa lang ka term, sir. Binomial na siya.
Okay, so take note, maghambak kita polynomial. It could either be classified into a So ang ginahambal naton or ang ginmention mga binomial is still considered in the family of polynomials. Ang nanging concern lang sa aton sang high school naton nga concepts is we were discussed separately of monomials, binomials, trinomials, and then polynomials. But still, overall, ang tanan-tanan ang concept nga discuss naton, starting with monomial as sa trinomial are still considered as polynomial. So kabay pa medyo ma-emphasize na sa aton. So tanan na sila, polynomial na sila Japan. So this means, ari polynomial siya of a degree 4. So bisan duwa lang na siya, still pwede siya natin i-consider as polynomial. So we have polynomial. Next one, what if we are given g of x is equal to 2? Is this a polynomial or not? Okay, so ang given sa aton g of x is equal to 2. So ginmention naton kagina ang function and we have here example na sa pinakauna nga term wherein dapat bisan duwa lang siya or any pila lang da ka components ng aton nga certain equation, polynomial siya. How about this time we are given ng certain constant. So can we consider this one a polynomial? Sige, Bifford, polynomial or hindi? Okay, so since medyo galang-alang patat para mag-answer kung polynomial or hindi, ako na lang mahambal. This one is still considered as, so both silingon, we have x raised to the power of 0 kung constant ni siya. So kay kung maghambal ka x raised to the power of 0, kabalo kita nga any number raised to the power of 0 will be equal to 1. That means may ara ta siya pon diri sa amo nga form of the equation. That means we have a polynomial of degree 0. So bisan constant lang, so it's still considered a polynomial of degree 0. Next, we have h of x is equal to 2 square root of x plus 1. So, amo niyang given sa aton. So, take note that it was mentioned in the general description of a polynomial nga dapat maghambal to polynomial, there should not be square root sa aton nga exponent. And we have here or I mean wala kita sang radical, so wala man kita sang fraction sa ating exponent. So if we have a radical sign sa aton nga equations, then we have to say na this one can be converted into a fractional exponent. So ang fractional exponents is not considered a polynomial. So kay hambal naton, we have an integer na negative integer. So this one, hindi siya naton makonsider in the integer nga form. Next one, if we have a certain function, 3 squared of x plus x squared, so is this a polynomial or not? So ang concern naton is dapat na negative integer. If we have this one, nga ang aton nga variable is ara sa aton denominator, this means nga we have a certain part or components sa aton nga equation or sa aton nga function wherein we have a negative exponent kung ara sa dalong mga aton nga variable. So this means so diri sa aton nga given nga value or sa aton nga equation, we have 3 all over x. So both silingon ara sa dalom ng x. So this one will be x raised to negative 1. So negative ang aton nga exponent. So this is not a polynomial. So if we have to identify kung ginhatag sa aton, for example, ang graph, and we have to identify kung polynomial na siya or hindi. So, paano natin mabalaan? So, graphs of polynomials are smooth and continuous. So, kinanglan natin tandaan. So, if hindi smooth or hindi continuous ang certain graph, hindi siya natin ma-identify as polynomial. So, here are the properties na pwede natin i-consider for a certain polynomial kung magtanaw kita sa graph. Dapat number 1, wala kita sharp corners, wala kita cusps. Next, wala kita graph, or wala kita gaps, wala man kita holes. So, but siningon kung mag-drawing kita, for example, sa papel, so pwede mo siya mag-draw without lifting your pencil from a paper. So, that is one of the I mean that are some of the properties of a graph of certain polynomials. So if we have here isang amo nga graph of a polynomial. So we have this one can be considered as a graph of a polynomial. So how about amo niyang itsura for example sa aton nga polynomial sa aton nga function. So can we consider this one a polynomial? So take note, dapat wala kita sharp corners or cuts, wala man kita dapat sang gaps. So we have here a gap and we have holes. So but silingon, wala nato na satisfy ang dapat nga property of certain polynomials. That's why hindi nga type of graph na nakita naton on the right is not considered a graph of a polynomial. Okay, so we were able to discuss in a previous session sa ating tutorial about the concepts of graphs nga nakita natin kung paano natin i-identify ang graph of certain functions. So let's look at the graph of your function of x is equal to x raised to the power of n. Kung ang aton diri nga exponent is an even integer, so anong itsura sa aton function? So if even ang aton nga exponent, ang itsura sa aton nga graph is pointing upward kag daw amo niya itsura daw letter U ang aton nga graph. So this one may tari tatlo ka type of graph. So take note lang kung anong ma-observe naton sa siniga graph. We have ang color blue. So we have x squared. For the color red na graph, we have x to the fourth and we have x to the sixth para sa aton nga green na graph. So ano ang ma-observe natin dere? It is evident sa sining nga graph that we have do paris-paris lang nga itsura sa aton nga graph. And we started with una-una mera kita x squared and then samtang nagataas ang aton nga exponents. So medyo we have medyo ga-flat na siya or medyo steeper ang ating slope. So, it grows steeper on either side. Samtang ga-approach kita. So, medyo ga-palapit siya sa negative 1 at this point sa ating graph. So, the higher the power, the flatter, and the steeper ang ating graph. So, take note, paris-paris lang tanan ng ating itsura, though x squared lang, pero medyo gapagamay lang sila. So, basta even ang ating nga exponent. How about if we have an odd integer sa aton nga exponent sang x raised to the power of n? Anong itsura sa aton nga graph? So we have here sa aton nga graph. So amo ni itsura sa aton nga graph. So we have pointing pa dito. So gapanaog siya sa mga third quadrant and then kapasaka siya sa aton nga first quadrant. So we have here x cubed, we have x raised to 7, and we have x raised to 5. So, amo ning ato ang itsura sa aton nga graph. So pares-pares lang itsura sa aton nga graph. So bisan medyo taas ang aton nga exponent compare with the other types of function. Pero since add ng aton nga exponent, still the same naman dapat ng aton nga graph. So notice that each graph looks similar to x cubed, but it is wider and flatter near the origin between -1 and 1. So same man with the concept of even integer, ang kakatabo diri is it grows steeper on either side yung kasaka ang atong exponents. So the higher the power, the flatter and steeper it is. So ang gin-introduce naton nga concept of graph of positive and negative exponents, gamito natin to identify or to bisan to approximate lang the certain graph of a function. So medyo this will be helpful especially kung for example you are in a calculus topic kag para makita nimo kung anong itsura sang graph sa imo lang bisan panumdumon mo na lang or bisan mag-draw ka lang sang simple lang nga graph nga hindi gid bala exact pero makita natin kundi lang minimum maximum values of a certain graph. So kabalo kita kagina that we are given for example sa una-una naton. Okay, so sa una-una naton kaginang napag-plastar on the graph, we have nakita to naton ang graph of x raised to 4. So x raised to 4, but silingon kay even ang atong graph but silingon u ang aton nga graph kay even kapasaka siya kay kon x raised to 4. But since we have negative, subot silingon imbes mapasaka siya, ma-reflect siya about x-axis or manaog siya. Wait lang. Okay, so again, nakita natin kagina sa graph nga kung positive ang aton nga exponent of a certain function, dapat ang aton itsura sa aton nga graph is gapasaka siya or letter U siya nga upward. So we have amo ni gapasaka dapat kay x to the fourth. But since we have a negative exponent here, so negative ang exponent, but silingon imbis mapasaka siya ga papanaog ang itsura. So amo ni dapat ang itsura. And take note, okay, this one, ang negative reflects about the x-axis. So, ang iya itsura, parehas lang sa x squared but wider. Near the origin, steeper at 1 kag negative 1. So, amo nang iya itsura. So, ang aton nga boundary will be alin sa negative 1 kag positive 1. So, medyo kapalapit da ang aton nga x raised to 4. Then, we have positive 2. This one, amo ni ang ma-change ng aton nga value. So, both silingon, we have to adjust. So, it moves upward. Halin kita sa aton nga origin, mapasaka kita, moves upward by 2. So, halin sa origin. So, that means, okay, ang muning itsura sa aton nga graph. So, we have, so, imbis diri kita dapat ma-start sa aton nga una-una nga graph diri ta dapat ma-start. So, nagsaka ta by 2 kami plus 2 kita. So, we add 2 diri sa diri nga point. Okay? So, and then, nag-reflect lang siya papanaog kay negative ang aton nga given na function. This time, we have here to identify isang behavior sa aton nga graph. So, left and right nga behavior sa aton nga graph. So take note that ang degrees ng ating polynomial along with the signs ng iyang coefficient of the term with the highest power amo na ang magbulig sa aton to help identify the left and right hand behaviors ng ating graph. So liwat nung kinanglan natin lang tawon to look at the left and right behaviors ng ating graph. Number 1, tanawon ta ang degrees ng polynomial. So next, another one, tanawon ta kung diin ang may highest power or diin ang may pinakataas na power sa aton nga polynomial. And then, tanawon natin din ang aton nga signs ng aton coefficient. So, sang may pinakataas nga, sang aton nga leading nga term. So, take note that even degree polynomials rise on both the left and right hand sides of the graph. Okay, take note lang ha. So, basta even ang aton nga polynomial, so kapasaka siya sa left, kapasaka man siya sa right. So, basta even ang aton nga polynomial. So, examples ini, again, identify natin kagina like x squared, we have x to the fourth, x to the sixth. So, take note that this will happen nga masaka sila nga duwa if ang aton nga coefficient or ang aton leading coefficient is positive. So the additional terms may cause the graph to have some turns near the center, but kalabanan or ang pinagid ka main concept bahala dapit kapilada siya mag turn sa tunga. Pero kabalo kita nga dapat masaka ang left, masaka ang right kung positive ang aton nga kung ang aton nga exponent is an even degree. So para sa aton nga polynomial. Okay, we have left-hand behavior pointing upward. So, ang ating right-hand behavior upward man ang yang direction. For an even degree polynomial, so gapapanaog siya or pointing downward siya. So, on both left and right hand, if ang ating graph is having a coefficient na negative. So, for example, negative x squared, negative x to the fourth, negative mga muna. So that is even degree nga polynomial pero negative ang ato niya coefficient. So we have, so gapapanaog siya on both left kag right nga parts ng ating graph. Okay? So pwede siya kapilada siya mag-turn in the middle sa ating graph. But we know nga the left and right hand behavior so gapapanaog siya because we have negative. Next one, we have an odd degree polynomials. So anong itsura kung odd ang atong exponent? So odd degree polynomials. So falls on the left, rise on the right. So again, gapapanaog siya diri sa atong nga left, gapasaka siya sa atong nga right. So falls on the left, rise on the right. Take note that this will happen kung ang aton nga coefficient is positive. Okay? So, suli sini, kung negative ang aton nga coefficient, anong matabo? Kung negative ang aton nga coefficient, anong matabo? So, we have, kung negative ang coefficient, suli kita. Dari kita masaka sa left. Okay? Masaka kita sa left and manaog kita sa right. So, kung negative ang aton nga coefficient, kag degree ang aton nga exponent. Okay, so we have sa amo nga properties ang aton nga graph. So we have a polynomial degree n can have at most n minus 1 terms. So whatever the degree is, what we have to do is subtract 1 to get the most times the graph could turn. So take note of the word most. So pwede nga most times the graph could turn. So this doesn't mean nga doesn't mean it does turn that many times, but that's the most it can turn. So, amo nang ginahambal ko. So, pwede nga nag-turn siya or pwede nga na-achieve niya gini ang n-1 or wala. So, let's determine the left and right hand behavior of the graph of the function. So, gamiton tani nga graph. So, kagina, we started with x to the fourth or binomial ang term or monomial ang gani for the graph kagina ang gina-identify naton for the odd and even degrees. But this time, we have here a polynomial ng gid para makita natin ang graph natin. Excuse. So, we have here a degree. So, nakita natin kung nagtawan natin atong leading term which is having a degree 4 which is even. And then ang aton nga coefficient. So, coefficient natin dere is positive. So, both silingon. So, the graph. So, ang itsura niya will be like x squared. So, x squared ang itsura. So since positive ang ating exponent, it looks off to the left and off to the right. So, ang munang itsura sa ating graph. Wala ko ako asan. So we have, ang ating graph will look like x squared. Ang muna ating itsura, it looks off to the left, looks off to the right. Since positive, kapasaka siya sa babaw, kapasaka man sa left, kapasaka man siya sa right. So the graph, so since ang aton nga pinakaayas nga degree sa aton nga polynomial is raised to the power of 4, but silingon ang aton nga graph, pwede siya maka-turn at most 3. Dapat mabuhin lang ta isa halin sa aton nga exponent. So at most 3 turns or 3 times siya mag-turn ang aton nga graph. So how do we determine what it looks like near the middle sa ating graph? Paano na ito mabalaan kung di siya nag-turn, sa di siya pwede mag-change ang slope sa ating graph? So, dari na masulod ang concept nga gin-discuss natin sa second natin nga tutorial sa second natin nga session or last natin nga session. So, we have to identify the x and y intercept sa ating nga graph. So, the x and y intercept would be useful and we know how to find those based sa ating first kag second nga discussion. So to find the y-intercept, himuon naton is to put 0 sa aton nga x. So butangan ta 0 ang aton nga x, and then automatic amo na dayon ang makuha naton nga value for the y-intercept. So pagbutang ka sang 0 sa tanan nga x, this one will be your answer. For example, so we have 30. So plot mo na dayon 0 ang x, y mo is 30. Okay? So mo na isa sa mga points of the graph. Next, find the x-intercept. So ang himuon naton to find the x-intercept, we put 0 in for y. So we have to discuss pa later on of the concept of factoring. So halin sa sininga graph or halin sa sininga function. So hindi ko danay pag-i-detail about factoring. But we have, so in order to factor this out, for example, nakuha tayo ni ang amuning nga factor of a certain function. So amuning nga ito ni tsura sa ating graph or amuning gamito nato for the x-intercept. So later sa sininga discussion, medyo balikan tama na ang factoring. Okay, that means based on the graph that we have, wait lang. Ferdeline,
Yes, sir.
nag-raise hand ka. May question?
Yes, sir.
May question? Okay, so let us continue. Again, so we have, for example, na factor na naton and pwede na naton dari automatic makuha ang aton nga y nga x-intercept. So we have x is equals to positive 2, x is equal to negative 3, x is equal to negative 1, and x is equal to 5. So para dali. So plot mo na dayon sa mga graph and we have this one. So our amo ning mga points naton nga kinahanglan mabalaan. So we have negative 3, 0, negative 1, 0, 2, 0, kag 5, 0. Amo na ang mga points sa aton graph. So finally, kinahanglan naton mag-form sang smooth nga curve through the intercepts that has the correct left and right hand behavior. So to pass through these points, it will have 3 turns lang dapat. Katatlo lang ta dapat mag-change ng direction. So tanawon mo lang or i-analyze mo lang kung di ka dapat ma-turn. So take note, we have this one. So pwede na natin makita kung anong mga itsura sa ating graph. So that means ang ating graph, so since halin dere, patatlo lang kita mag-move, so we have this one, change direction and change direction. Katatlo kita change direction. So ang itsura naton kung sa graph, grid or graphing calculators or any form of graphing nga mga software, ang itsura will be like this one. So, ang maning itsura. So, hindi man naton exactly gid ma-identify kung ano gid ang itsura niya, but at least we know kung ano ang mga behavior sa aton nga graph sa aton nga graphing. So we found the x-intercept by putting 0 in for the function of x or y. So we call the x-intercept the zeros of a polynomial. So in some of the books or bisan in the concept of algebra gin discuss aton before, wala gid na mention nga kung nag-factor kita sa certain equation ginatawag na siya gali as zeros of polynomial. This time I would like to present new concept. So it's not if hindi lang siya pwede hindi lang factor of a polynomial ang tawag sa iya, but pwede man siya natong tawag as zeros of polynomial. In some of the mga exams, some of mga base ma-encounter ninyo dason ng mga exercises or sa ibang mga subjects. So, ang ginapamangkot is somebody wants to join, wait lang gid. Okay, so again, so para magpangita kita sang ah, para makuha nato ng x-intercept. So ang ginahimo naton is ginalet naton ang y or ang aton function of x equals to 0 and then gina-factor na siya naton. So that's why ang tawag sini sa una-una naton yung concept of discussions algebra naton ng mga classes so or sa junior high school pa natin yung mga discussion ginatawag siya naton as factor of a polynomial. But take note also na ginatawag man ni siya sa ibang nga concept or higher concepts of mathematics as zeros of polynomials. Especially sa mga entrance exam or mga amo na nga mga discussions or any type of assessments ka pwede nyo maka later on. So may mga questions nga pamangkot is find the zeros of polynomials. So do not be confused of the term. So maghambal find the zeros of polynomials. So ang himuon mo lang is to factor a certain polynomial and equate it to 0. So that is for the zeros of polynomial. So that means factor of polynomial, zeros of polynomial, roots of polynomial, medyo related lang silang mga terms. Okay? So we have here given isa ka polynomial, naka-factor na siya daan. So we have x minus 1 cube, x plus 2 squared, and we have x minus 3. So take note, we have a repeated factor of x minus 1 kaya naka-raise siya sa power of 3. So it is repeated 3 times. If we set this equal to 0 and solve, we get x is equal to 1. So x minus 1 is equal to 0. So we have x is equal to 1. So we then say that 1 is the 0. 1 is a 0 of polynomial of multiplicity 3. Both silingon, katatlo, ka-value ang 3. Next, we have Ari. So, iban pa nga zeros. So, we have iban pa nga zero of polynomial. So, himuon mo lang is equate ng sa 0. We have x is equal to negative 2. So, we have negative 2 of multiplicity 2. But silingon ka duwa ay exponent or 2 ay exponent. Next, we have equate mo ni sa 0. We have x is equal to 3. X is equal to 3. So both silingon, we have a 0 of polynomial which is equal to 3. 3 is a 0 of polynomial of multiplicity 1. Kay 1 lang ato nga exponent. So knowing the zeros sa aton nga polynomial, we can plot them on the graph. If we know the multiplicity of 0, it tells us whether the graph crosses the x-axis at this point. So, ang add ng multiplicity, both silingon, ma-cross siya sa sinanga point. Both silingon, ma-cross siya sa sinanga point. Or whether it just touches the x-axis and turns and head back the other way. Para sa even multiplicity. So kung even ang multiplicity mo, both silingon, matouch lang siya, hindi siya mag-cross. So mamo lang na. So hindi siya mag-cross a certain point. So hindi magkamuni. So for the even nga multiplicity. So let's try the graph. We have negative x minus 1. We have x multiplied by x plus 2 squared. So what would be the left and right hand behavior be? Okay, so ano yan ang behaviors ng sininga graph? Okay, so if given sa ato ng ininga graph or ang ininga form of polynomial, so you don't need to multiply this out, but figure out what the highest power of an x would be if multiplied out. So tanawan ta lang, anong pinakataas dari naton nga exponent. So it would be, so may ara kas 2, so we have squared, then may ara ka di another x which is equal to 1. Both silingon, ang aton nga graph we have 2 plus 1 is equal to 3. Amo na nga aton nga pinakataas nga exponent. In this case, it will be x cubed. So notice the negative out in the front. We have negative nga exponent diri. Or nga coefficient. So that means, so kung positive tani ang aton nga x cubed, diri ta dapat manaog, and diri ta dapat masaka sa right. Since negative, both silingon, diri ta masaka sa left, diri ta manaog sa right. So what would be the y-intercept? So what would the y-intercept b. So himuon mo for the y-intercept, let x equals to 0. So kung ma-0 ni, ma-0 man ni, so negative 1 times negative 1, that is positive, then we have 2 squared na lang. So that will be equal to 4. Y is equal to 4. So we have, that's why we have a y-intercept yung 0 and 4. Next, nakuha na natin ang y-intercept. Pangitaon natin sa buong ang concept or ang aton nga zeros and their multiplicity. Zeros of polynomials naton. So, pwede ito man lang makita diretso. So, we have x minus 1. So, we have x is equal to 1 para sa sining factor. And next, we have x minus 2 or x is equal to negative 2, negative 2. So we have 1 dere of multiplicity 1, negative 2 of multiplicity 2. So since we have para sa 1, so 1 lang iyang exponent, so both silingon, it crosses the x-axis. Kay 1 ang iyang exponent, crosses. Next, we have ang aton exponent for negative 2 nga zeros is 2. Even ang aton exponent. Both silingon, at that point, it touches at negative 2. So, it touches at negative 2. So, ano subang itsura sa aton nga graph kung i-plot naton? So, we have negative 1, or we have positive 1 and negative 2. So, sa negative 2, it-touch lang. So, ga-touch lang siya, wala siya nag-cross. So, negative 2, nag-touch lang. Then, nag-turn siya dayon. For the positive 1, nag-cross siya. So, bosilingon na naog siya. Diretso. Okay? So, we obey sa aton nga rules nga gina-discuss. So, nagsaka siya sa left, nanaog siya sa right. Next, nag-touch lang siya sa may ara sang even multiplicity. Nag-cross siya sa may odd multiplicity. And then, may ara kita duwa lang ka turns diri. Which is, pinakataas ng exponent is 3, so n minus 1 sina is 2 lang. So kaduwa lang ta dapat mag-turn. Okay, so here are the general steps for graphing a certain polynomial. So determine the left and right hand behavior by looking at the highest power on x and the sign of that term. So next, kaya una tayong ginhimo kagina, pwede na natin ma-estimate, pwede natin ma-identify dayon kung ano nga itong left and right hand behavior kung tanawan natin ang highest power on x. So una-una lang tawon, highest power on of x kung ano iyang sign. Next, determine the maximum number of turns in the graph. So by subtracting halin sa degree. So halin sa degree niya nga makita naton subtract 1. Sa amo na ang maximum number of turns naton. Next, pinakahapos, plot naton ang aton nga y-intercept. Paano identify ang y-intercept? So butangan tanan nga x, ilet naton as 0 for the y-intercept. Next, find the zeros or the x-intercepts by setting sa aton polynomial equals to 0. So, pag magpangita kita sang x-intercept, let y or your function of x equals to 0, then factor or solve naton ang mga ang aton nga equation or ang aton nga polynomial. Next, pangitaon or identify natin multiplicity of zeros. Nga kinanglanon natin ang multiplicity of zeros. Identify kung nag-attach or nag-cross ang aton nga graph at a certain point. Next, himuon natin is to join the points together in a smooth curve, either touching or crossing zeros depending on its multiplicity and using left and right hand behavior as aton nga guide. So if you need more accuracy sa aton nga graph, pwede ka nga ma-plug in kada ikaw mga hatag value of x and then pangitaon natin ang corresponding values ng y. So at least you have a concept na kung paano natin bala makita, paano natin mag-gauge ang graph of a certain polynomial. So even sometimes, makita lang natin bala kung diin siya ga-touch, diin siya ga-cross in a certain sa aton nga coordinate system. Okay, I have here a function of x which is equal to x squared multiplied by x minus 3, and we have x plus 3. So, una-una natin himuon. Let us determine the left and right hand behavior by looking at the highest power in x and the sign of that term. So, multiplying out, highest power would be, so may ara kita dari 2, so 2 plus 1 plus 1. So we have ang pinakataas natin nga power would be x raised to the power of 4. So ang muna pinakataas natin nga possible exponent, 4. So both silingon, nyara kita sang even degree polynomial. So kung even ang ating nga polynomial, we know nga ang ating nga polynomial will be upward ang iyang left and right hand behavior. So both silingon kapasaka siya sa left, kapasaka man siya sa right ang ating nga graph. So, since wala kita sang sign nga negative sa aton nga leading term or sa leading coefficient, so that means maintain naton nga pasaka siya sa left kag right hand nga niya nga side. So, next naton nga himuon, determine the maximum number of turns in the graph. So, ang himuon naton, subtract lang ta with the highest degree. So, subtract 1 from the degree. So, aton degree is 4 to kagina. So, subtract lang ta. So, degrees 4. So, ang maximum number of turns would be 3. So, maximum number of turn would be equal to 3. Next, himuon naton is to plot the y-intercept by putting 0 in for x. Tanatan nga x, butangan ta 0. So, we have 0. This will be 0. This will be 0. This will be 0. So, we have, this will be 0, 0, 0. So we have negative 3 times 4 will be equal to negative 3 times 4 times 0. So 0 times negative 3 times 4 will be equal to 0. So both silingon, aton nga y-intercept is at this point when we have the x-axis. Okay? Next, find the zeros or the x-intercepts ng atong nga polynomial. So, by letting sa atong polynomial equals to 0. And then, pangitawan natin ang atong nga factor. So, ileta lang equal to 0. So, we have 0 is equal to x squared. 0 is equal to x minus 3. 0 is equal to x plus 4. So, we have zeros natin will be okay, so we have this one will be 0, this one will be x is equal to 3, this one will be x is equal to negative 4. So aton zeros are 0, 3, and negative 4. So kung i-plot natin, we have your this one negative 3, this one x is equals to 0, we have x, this one is x equals negative 4, this one is x is equals to 0, this one is x is equal to positive 3. Next, determine the multiplicities of 0. Okay, ang aton nga 0, sa diri nga point, we have 0 naton is 2 ang aton nga exponent, subot silingon, it touches lang sa sinang point. So, it touches. Next, for the 3 and negative 4, so isa lang or 1 lang ating exponent, that means it crosses. So, ga-cross siya sa x is equals to 3 kag x is equal to negative 4. So next natin nga himuon is to join the points together in a smooth curve. So depende sa na-identify natin kung ga-touch na siya or ga-cross on its basing on its multiplicity. So we have kabalo na tasang mga itsura niya. So we have makross siya sa negative 3, matouch lang siya sa sininga point, and then ma-cross siya sa this is negative 4, makross siya. This is positive 3, makross siya. Sa 0, ma-touch lang siya. So, ang aton nga graph will be, okay, kapamo ng itsura. So, kapasaka, tanan ng aton nga, ang aton nga graph will be, kapasaka, dari sa left, sa right, So crossing sa negative 4, touching 0, crossing sa positive 3. So actually, in the actual gid nga graph, I have this one. So how sa graphing gid, amo ni aton mga itsura. So at least in the um, graph naton, so medyo ma-approximate na naton kung ano nga aton mga itsura. If you want get sa pinaka-exact nga value, so pwede mo man ma-plug in ka di values, and then lang tawan nimo ang kung di siya may kung ano gid kung gusto mo exact nga value. But this is good na for the graph sa aton nga function. This time, what if we thought backwards? Given kita sang zeros and the degree, can you come up with a polynomial? So we have find the polynomial of a degree 3 that has zeros negative 1, 2, and positive 3. I think this will be helpful para sa inyo or medyo easier niya nga concept kung kamo ang multiply. So medyo hapos-hapos ni para sa aton. So what would be the function look like in a factored form to have the zeros given above? Okay, so we have himuon mo, i-change mo lang ng sign dali. So kay kung mag-substitute na tayo ni certain polynomial, so i-change na yung sign, we have x plus 1, so we have kay negative d may mo siya positive x plus 1. Kung 2 dari may mo siya negative, we have negative 2. So we have 3 may mo siya negative 3. Okay, kaysa aton nga polynomial, ginahin mo na siya x minus a. So ma-change na ang sign. So negative na rin sa tunga. That's why gina-change natin ang sign. Nag-positive siya, nag-negative siya, nag-negative siya. So multiply this out to get the polynomial. So FOIL two of them and then multiply by the third one. So any possible ways nga pwede nimo himuon to expand sa sining equation. So we will come up with the equation x cubed minus 4x squared plus x plus 6. So amo na siya nga aton nga equation for this one. So this will be easier na lang sa inyo kay multiply lang man, expand sa certain nga equation. So ang pinaka concept lang man dali nga introduce ko is the zeros of polynomial kay medyo helpful sa in the concept of finding the graph of certain polynomials. In the last natin nga discussion, I presented rational functions. So, rational function this time, balikan ta siya, but in the concept of graphing. So, kung nag-graph na ta sang rational functions, ano ang iya mga itsura? So, steps to graphing a rational function will be the following. Number 1, so based at nga previous nga discussion, himuon naton is to find the domain. So, excluded ang values. So, where are excluded values are where your vertical asymptotes are. So, makita man nato ang aton nga vertical asymptotes based on the value sa aton nga denominator. Next, pangitao nato ng aton nga y-intercept. If there is one, remember we find the y-intercept. So, pares man Japon, letting x is equal to 0 para sa y-intercept. Next, pangitaon taman ng x-intercept. So, if there are any, by setting the numerator of the fraction equals to 0. And solving. Next, so take note x-intercept para sa numerator isang fraction. Test for the symmetry. So paano sir? So balikan natin ang concept natin on the second natin na tutorial session wherein we have to test for the symmetry sang aton nga equation imbes nga x is lang ta siya negative x. So remember even and add test of the equation. Next, we have horizontal or oblique asymptotes by comparing the degrees. Next, find some points on either side of each vertical asymptote. So, find some points on either side of each vertical asymptote, then connects natin ang atong nga points and head towards the asymptote. Okay, so we are given here an example ng function wherein we have 6 all over x squared minus x minus 6. So, una natin himuon, find the domain. So, excluded ang values kung diin natin ma-identify ang atong vertical asymptotes. So, we have x squared minus x minus 6. So, we have, so base 3, we have x squared minus x minus 6. So, pwede kita natin ma-factor. So, we have x minus 3 and we have x plus 2 ang aring equation. So, pwede natin mo kaadri ang values ng atong x. So, we have this one. So, ang ari, may mo siya x is equal to 3 dapat. So, x is equal to negative 2. So, take note, maghambak kita vertical asymptote, dapat at that point, hindi dapat mag-zero ang ating equation. So, that's why, dapat, ang ari nga mga value nga gin-solve natin, x is equal to 3, x is equal to negative 2, hindi ni siya dapat mang-impart sang domain sa ating equation. That's why, hindi dapat pwedeng x is equal to 3, so based diri sa ating ginsuma, and x is equal to negative 2 para sa ating domain. Because this one will make the equation ang ating denominator be equal to 0. Okay, kaya kung i-substitute di siya, ang ating mga values, ma-0 ang ating denominator. Okay? Next natin nga himuon is to find the y-intercept if there is one. So remember, pangitaon natin ang ating y-intercept by putting 0 in for x. Okay, so we have, para sa y-intercept natin, so butangan mo lang ni 0, tanan-tanan, ng x. So ang mabilin, we have 6 divided by negative 6. So that will be equal to negative 1. Okay, para sa ating nga y-intercept. Next, find the x-intercept if there are any by setting sa atong numerator sa atong fraction is equal to 0. So if the numerator of the fraction is equal to 0, then the whole fraction is equal to 0. Since 0 over anything is equal to 0. So, but 0 is equal to 6 is not true, which means wala kita sang x-intercept. Okay, so wala ta x-intercept para sa sininga function. That means wala kita nag-touch sa atong x-axis sa sininga graph. Next natin nga himuon is to test for symmetry by putting sa atong negative x sa atong x. So ano subong mga itsura sa atong nga graph? So we have negative x squared minus negative x. So islanta lang negative tanan ni x minus 6. So that will be equal to 6x squared plus x minus 6. And take note, ma-identify to siya nga symmetric siya at x-axis if, so we have, mabalik siya sa imong original equation. Since this is not equal to the original, so and not negative of the function, so neither even nor odd ang ating function. So, wala siya nagbalik sa atin nga equation. So, next one, tanaw natin ang horizontal or oblique asymptote. So, by comparing sa atin nga degrees. So, amo natin yung ginhimo last time. So, degrees ang atin nga numerator is equal to 0. So, since function lang or constant lang siya, we have x raised to 0 na siya. Next, for the degrees ang atin nga denominator, we have, so 2 para sa atin nga degree. So if the degree of the top is less than the degree of the denominator, the x-axis is the horizontal asymptote. So kung mas taas sa aton nga denominator, so ang aton nga degree, o mas taas ang degree sa imong denominator kumpara sa numerator, so we have the horizontal asymptote naton as the x-axis. Next, find some points on either side of each vertical asymptote. So choose an x on the left side of the vertical asymptote. So mangila tadi. So again ha, balikan ko lang ha. Since we have kabalo kita, ang atong x-axis is the vertical asymptote. Kaya mas taas ang atong degree sa denominator sa atong nga numerator. So we have na lang, we have the blue nga line para sa atong nga horizontal asymptote. Next, mangita ta some points on either side of each vertical asymptote. So, choose an x on the left side. Mangita lang tada values ang x sa left side of the vertical asymptote. And then, himuon mo lang isu-substitute values. So, mangita lang tadi point or x na value and then substitute lang diretso. So, we will come up with the value. Okay? So, ari na lang yung diretso ko na lang substitute y naton or r of x will be equal to 2.4. Next, choose an x between the interval. Okay, mangita ta the value of x. So, for example, we have positive 1. So, kung i-substitute ta value, that will be equal to negative 1. Next, choose an x on the right side of the equation. So, or the right side sa aton nga vertical asymptote. And we have this one. So, ginpili ko diri nga value is 4 or positive 4 and mo come up tas ang answer nga y is equal to 1. So may ari natin nga points sini nga graph. So connect points and head towards the asymptote. So pwede tadi maka-connect sang points and then dapat medyo touching ka or ga-touch ka sa imong mga asymptotes. So there should be a piece of the graph on each side of the vertical asymptotes. So dapat may ari ka gidi dapat ga-touch medyo gapalapit ka diri nga graph, gapalapit ka sa sini nga graph. So medyo may ari ka di dapat. May ari ka mo di sa vertical asymptote. Okay, medyo lapit ta nga graph. May ari ka mo di sa horizontal asymptote, gapalapit dira nga graph. So pass through the point and head towards your asymptote. So, okay, so ga-touch medyo gapalapit ta sa sini nga graph, gapalapit ta sa sini nga graph. Or sa sini nga asymptote. Pass through the points and head towards the asymptote. So hindi ito pwede makasaka, can't go up, or it would cross the x-axis. So hindi tadi pwede mag-cross kami asymptote o may ari man tadi horizontal asymptote. So but silingon somewhere diri lang, medyo kapalapit lang ta sa aton nga x-axis. So but silingon aton graph will look like this one. Hindi ta pwede ka cross dira. So pass through the point and head towards the asymptotes for the right side sa aton nga equation. So ang aton itsura sang graph will be like this one. Medyo ga-touch lang siya sa aton yung mga asymptotes. So this one, take note, medyo budlay tani kung i-graph mo siya. But this time, because we know the concept of graphing, medyo na-identify nato ang aton nga graph. Okay, if we go to the function grapher or graphing calculator, so makita naman natin ang graph niya, which is similar or medyo pares-pares sa sini nga graph. This time, let's try another one with a bit of twist. So we have x squared plus 4x plus 3 and over x squared minus 9. So una-una naton himuon is to find the domain sa aton nga equation. So we have, wait lang. Wait. Okay, so we have given sa siling equation, ang una natin ang imuon is to find the domain. So we have, so to find the domain, so ang aton ni consider is the denominator sa aton nga rational function. So we have x squared minus 9 is equals to 0. So we will come up with, so since this is a difference of squares, so we have x plus 3, x minus 3 sa aton nga factored form. And we have x. So, kay kung graph naton, kung i-graph naton ang aton nga function, okay, do not be confused. Okay, do not be confused ang array. So, because kung ang ginapangita sa inyo is factor nga form, or ang value of the equation. So this one, kung nag-graph kasi ni x is equal to 3 na siya. Kung for example, x is equal to negative 3 na siya, kung nang ginapangita sa inyo is value of x. Or this one will be x is equal to 3. Since ang atong subong ginapangita is vertical asymptote, so ang gina-consider natin is domain of the equation. Hindi lang ma-confuse, guys. So we have, that means kung sa domain, hindi dapat included ang negative 3 kag positive 3. Kaya mahimo niya ang aton equation equal to 0 or ang aton nga denominator. So hindi ma-confuse kung factoring kag domain ang ginapamita. So for factoring, aton answer will be x is equal to negative 3, x is equal to 3. So for the factoring ni guys. Kung amo niya ang aton kung amo niya aton answer. Pero if domain, both silingon dapat consider ta lang ang denominator. So domain, so x is equals to, x will be any possible values of real numbers except negative 3 kag positive 3. Kay mahimo niya ang aton nga denominator equal to 0. But notice that somebody wants to join. Okay, but notice that the top of the fraction will factor and the fraction can then be reduced. Okay, so we have x plus 3, so pwede natin ma-factor ang sa babaw, x plus 3 times x plus 1, and we have x plus 3 times x minus 3. So we have a vertical asymptote from this factor only since other factor will be cancelled. So if basihan ta lang kagina ang aton nga original nga process nga ginagamit, so pwede naton magamit ni. But pwede giri naton danay ma-simplify ang ating equation in order for us to identify sa pinaka-insakto nga vertical asymptote. So aton lang vertical asymptote will be equal to x minus 3 kung i-equate ni. So both silingon hindi pwede nga mangin positive 3 ang aton answer kay ma-0 ang aton nga denominator. We will not then have a vertical asymptote at x is equal to negative 3. So sa x is equal to 3 na lang aton nga asymptote. Okay, so we now have a reduced fraction. But we must keep in mind that x is not equal to negative 3. So, based sa aton nga graph, sa aton nga values kagina, hindi man dapat pwedeng ang x natin will be equal to negative 3. Kaya ma-zero man ang aton denominator. But we were able to reduce ang aton nga equation into this fraction. Find the y-intercept if there is one. So remember, we find the y-intercept by putting 0 in for x naton. So butangan ta 0 tanan-tanan nga x, we will come up with an answer wherein we have negative 1/3. So let's plot the y-intercept. So which is 0. So y naton will be negative 3, 0 aton nga x, negative 1/3. So graph ta siya, ari aton nga graph subong. Next, mangitaon ta ang aton nga x-intercept if there are any. So by setting sang aton numerator equals to 0. So sa numerator na lang ta. Okay, so for the numerator, equate lang ni sa 0. So we have if the numerator kay amo ni aton nga lantawon, so ma-0 ang aton nga function kung ang aton numerator will be equal to 0. So we have equate lang x plus 1 is equals to 0, both silingon x is equal to negative 1. So ang aton x-intercept will be equal to negative 1 and 0. Negative 1, 0. So to test for the symmetry, so himuon naton is to let ang aton nga x equals to negative x. Tanawon ta lang kung mabalik siya sa aton original equation. So aton nga equation will be equal to negative x plus 1 which is not equal sa aton nga original equation. Next, himuon naton, pangitaon naton subong. So may ara ata vertical asymptote, may ara ata horizontal aton nga x kag y axis. So ang kulang na lang sa aton is the horizontal or oblique asymptote. So we have to compare the degrees. So ano subong aton nga degrees? Degrees ang aton numerator is 1, degrees ang aton denominator is also 1. So since pareho sila nga duwa, if the degree of the top equals the degree sa aton nga denominator, then there is a horizontal asymptote at y is equal to leading coefficient sa aton nga numerator divided by leading coefficient sa aton nga denominator. So divide na lang na. So aton coefficient is 1 para sa numerator, 1 man para sa aton nga denominator. So we have 1 divided by 1. So aton nga y is equal to 1. So ari na siya sa aton nga graph, diri ang aton nga horizontal asymptote. Next one, find some point on either side of each vertical asymptote. So we have to find the values either side of your vertical asymptote. So we already have some points on the left side of the vertical asymptote. So we can see where ang ating function will go. So let's choose a couple of x on the right side of the vertical asymptote. Okay, sa right side sa ating vertical asymptote, so we have 4. So pilion ko lang 4. So kung i-substitutean ko siya value sang 4 sa ating equation, akon nga equation will be equal to 5. So that will be the value sang akon nga y. Next, mangita pa ta ibang nga value. So we have, for example, 6 ang aton kwaon. So 6 will be aton nga value for y. Kung substitute ang 6 will be equal to 2.3. So that will be, so i-plot ko lang. So I have this. Next, pwede ta makakonect points and head towards the asymptote. So kabalo kita nga dapat near diri may ara ta graph, near diri may ara ta graph, near diri may ara ta graph, and near diri may ara ta graph. So there should be a piece of the graph on each side of the vertical asymptote. So pass through the points and head towards the asymptotes. Pass through the points and head toward the asymptote for the right side sa aton nga graph. Remember, based sa aton nga pagsuma kagina, dapat x should not be equal to negative 3. Kay mahimo niya nga aton nga equation equal to 0. So ang himuon naton, make a hole sa sini nga graph. That means, butangan ta, kay ang imo nga graph, butangan mo lang da circle. So para sa sina nga point. Okay, so amo na siya kung mag-draw kita sang graph. So kung may mga hole or ang aton nga specific nga function. Okay, if we will look at the graph sini nga function in a calculator, we will come up with the pares-pares ni nga graph man Japan. Okay? So pares-pares na nga graph. This time, since na-notice natin kagina, we have a specific functions nga kinanglan naton mag-perform sang factoring of polynomials para ma-identify naton ang zeros of polynomials which will be helpful sa graphing naton of the equations. So subong, medyo balikan ta ang concept of factoring para sa certain graph of polynomials. So starting with the very basic factoring process, we have 15 minus 5x sa aton equation. So ano ang naton ginihimo? Ginihimo naton is to factor kung anong common sa sina nga terms of polynomials. There is a 5 in common in both terms that we would factor out. According to the directions, though, we are supposed to factor out a negative real number. So let's factor out a negative 5. So negative 5 para mag-positive ang mabilin. So factor it ang negative 5. So we have negative 5 times negative 3 plus x. So we have negative 5 times negative 3 plus x. So remember, you can always check to see if you've done this step correctly by redistributing through. So, pwede mo ma-check by redistributing sa ating equation. So, we have 15 minus 5x. Kung i-check na ito ng ating equation. So, okay, so take note, kung gusto sa iyong nga teacher nga naka-standard form ng equation, dapat una ang may variable. So from the highest exponents, so pa naog sa may mga nagagmay nga exponent, ang pinaka-last part naton is a constant nga term. So we have 3z plus 3 all over 8. So, ang pinakahapos dari nga i-factor out naton. So, given dari kuno dapat ang gin-emphasize dari sa equation. So, naghatag na siya daan. Gusto niya himuon naton nga common term ang 1/8. So, anong mabilin dari, ano ang kulang dari. So, factor out ako ng 1/8 halin sa sining equation. Okay, think what number divided by 8 will be equal to 3. So, paano na lang natin himuon? So that will be 8 divided by, anong denominator ang 3? So 8 divided by 1, so that will be equal to 8. 8 times 3, so that will be equal to 24. So we have 24, dari 24z plus, next we have 8 divided by 8 is equal to 1 times 3, that will be equal to 3. So we have divide mo sa denominator, multiply sa numerator. So that will be 24 and we have 3. Okay, kung gusto natin i-multiply liwat, we will have 24 over, kung i-check natin, kung i-check natin na factoring, 24 over 3z, and then we have 3 all over 8. So we have 24 over 3, so may mo lang man siya. Okay, so guys, we have 24 over 8 dili guys. So 24 over 8, which is equal to 3. Next, we have 4 terms. So when you see 4 terms, it is a clue to try factoring by grouping. So this time, paano ni sir naman i-factor? So look at the first 2 terms first to see what is in common. And then look at the second 2 terms kung di kita pwede maka-factor. So we have first nga 2 term, we have 4u to the 4th, and then we have 6u. And then we have second term naton nga 2u cubed plus 3. So start at danay. For the first 2 terms, we have 4u to the 4th minus 6u. Pwede tayo ka-factor out anong common sa ila. So we have common sa ila is 2u. So we have factor 2u raised to 3 minus 3. So, kung i-factor ta. So, 2u to the 4th minus 2u. So, mabili na lang 4 divided by 2 will be 2. u to the 4th divided by u. So, mabili na lang u cubed minus 3. So, next, para sa atin nga second 2 terms. So, we have second 2 natin nga terms will be negative 2u cubed plus 3. So, kung i-factor ta, so pwede tadi ka factor negative 1. So, ang mabilin, negative 1. So, ang mabilin, we have 2u cubed minus 3. So, ang muna natin nga, factors ng second natin or the last natin nga 2 terms.
Kaya mo yung last ni 8 mo?
Oo. Okay? So, take note subong, may ara kita another common nga term sa sining functions naton. So we have 2u cubed minus 3 nga common sa duwa. So pwede ito siya i-factor liwat. We will have 2u cubed minus 3 and then we have 2u minus 1. Okay, so imbis nga concept naton nga dapat ma-perform kita long division, so pwede siya naton ma-factor by grouping. But take note that not all equations pwede natin ma-applyan sa factoring by grouping. So there is a certain nga mga functions or equations or polynomials nga pwede ginaton magamitan sang factoring by grouping, pero not at all times nga mangin applicable na siya. Example, we have 9z squared minus 25. Ano ihan nga approach ang pwede natin himuon for factoring of this certain polynomial or certain functions or equation? So when you see two terms, look for the difference of square. Okay, so pinakahapos, so identify natin kung perfect square ni. Ang 9 ay han perfect square. So pwede siya ma-square root? Yes. Z squared, pwede siya ma-square root? Yes. 25, pwede siya ma-square root? Yes, pwede siya natin ma-square root. So, himuon natin. So, pwede na siya ma-square root. So, ang pinaka-square root ng 9z squared will be 3z. So, we have squared na lang diretso minus 5, then squared diretso. So, that will be aton nga squared. So, kung amo ni ang given, so perfect square ang first term, perfect square ang second term, and then separated sila by a minus sign. Para yun sa previous natin nga discussion in the last natin nga mga sessions. So, automatic ma-plus minus kita. So, we have 3z and we have 5. So, difference of square ang tawag sila, kaya ang ating nga mga factor will be 3z plus 5 kag 3z minus 5. So before kita mag-proceed, I just would like to ask, basta may mga clarification, may mga question, Jaina? May question? Hana, basta may mga question, the Edmar, Jefford, kag Ferdy, basta may mga may mga question, pwede kita clarify. Hindi mo mag-clarify or mag-interrupt if may mga questions ka mo. So we come up with the difference of square. Kita natin. So automatic na lang we have 3z plus 5 and we have 3z minus 5. So tawag sini basta parehas ang ating first term, parehas ating second term, and then separated lang sila by lain nga sign, positive sa piak, negative sa sign, sa piak, tawag na aton sa ila is conjugate pairs. So take note lang of the term conjugate pairs. How about this one? We have naka-cube. So cube ang first term or ang aton nga pinakataas nga exponent. So if it's not a difference of square, see if it is a sum or difference of cubes. Is the first term something cube or raised to the power of 3 or third power? Is the second term something cube? Okay, so check natin. 27s cube is a cube. So 27, pwede ihan ma-cube. So yes, 27, so pwede siya ma-cube. So 3 raised to 3 cube will be equal to 27. So S, naka-cube naman siya automatic. So pwede siya ma-cube. 64, pwede ma-cube. So we have 4 cube. So paano siya dahil natin i-factor? So we have, so can be a sum or difference of cube. So na-check ta. You must just memorize this step to factor the cube. You should try multiplying them out again to assure yourself that it works. So we have, himuon naton, first factor comes from what was cubed. So kung anong cube naton, amo naton unang-unang factor. So we have 3s, and then we have 4, or positive 4. So 3s plus 4. Next, square the first term. So square sa first term natin is 3s So squares ng 3 is 9, squares ng s is s squared. So we have first term natin. Next, multiply together but change the sign. Multiply together but change the sign. 3s kag positive 4. 3s times 4, that will be 12s. Change dahil ng sign, that will be negative 12s. Next, square the last term. So square the last term, so you have 4. So 4 squared is positive 16. So that is now ang perfect nga factor sang sini nga term. Okay? So take note, yung copy talang positive 3s, positive 4. Next, square ang first term, 9s squared. Okay? Square ang last term, positive 16. Para sa middle term, i-multiply ang duwa pero i-change ang sign. 3s times 4 will be 12s pero i-change ang sign, that will be negative 12s. This time, let's try another example. We have 64v cubed minus 125. So, what cube would give the first term? So, we have 64v cubed. So, ano na yan ang yung cube root? So, we have 64. Ano nga term ang kung i-cube mo siya, may mo siya 64. So, we have 4. So, 4 cube will be equal to 64. So, since v na dingalan ng given, we'll have v cube. Then, for the negative 25, that will be equal to negative 5. So, negative 5 cube. So, we have, nakita na natin ang aton nga factor for the first and second term. So, what we will be doing is pareho sa ginhimo natin kagina. So, copy ang first, ang aton nga term. So, 4v minus 5. 4v minus 5. Next. First term is square natin. 4v squared. So we have 16v squared. Kung squared ang 4b, may mo siya 16v squared. Next. For this second term natin, middle term, we have to multiply this one. 4v times negative 5. That will be positive. Or dapat ang answer is negative 20, pero i-change ang sign, so we will have positive 20v. Next, square ta ang last term. Negative 5 squared will be positive 25. Okay? For the last term natin. Okay, so medyo sakit pa nga factoring kung kamo lang ang ma-perform based on the concept nga nabalaan ninyo. Kay ginahimo naton, kinahanglan pa natin mag-divide by certain function. But this time, medyo simpler ni siya nga concept of factoring sa aton nga cube root nga functions. So when it just says factor completely, so rule number 1 of factoring says, himuon naton is to look, number 1, for the something in common, or ang common sa aton nga functions. So kung may ara common, that will be easier to factor, or pwede na natin siya ma-isolate sa aton nga equation. So after you factor out any common terms, see if you can factor what is left with the difference of squares, or sum, or difference of cubes, and don't forget to factor out in front that you took out. So, apply the concept of difference of squares or sum of difference of cubes kung may ara ka mo makita sa certain nga function. Okay, so for example, we have a cubed minus 16a. Is there anything in common? So, there is something in common sa sininga equation wherein we have may ara ta a sa first term, may ara ta a sa second term. So, pwede tayo factor ang a. We will have a squared minus 16. So now factor what is left in the parentheses. So we have, so since nakita natin a is perfect square, so ang aton 16 is perfect square man, so pwede natin siya ma-express as difference of square. So we have a plus 4 kag a minus 4. So that will be ang itsura or ang aton nga factors ang aton nga equation. Next, we have, let's try a medyo medyo difficult or medyo complex nga factoring. So we have 81 minus 16 y raised to 4n. So is there something in common sa aton nga equation? So we have 16 minus or 81 minus 16 y raised to 4n. So wala sang common sa aton nga first kag second term. So is this the difference of square? Is this the difference of square? So inspect nato ng aton nga first term kag second term. Perfect square ba lang 81? Perfect square ba lang 16 y raised to 4n? So 81 kabalo kita nga perfect square siya. How about 16? Ang 16 perfect square siya. Ang y raised to 4n basta even number ang aton exponent, pwede siya ma-express as okay, so medyo kulang ko guys, we have 4n squared dapat. So sala lang ko guro pagsulat. So where did this come from? Ay, check to guys, 4n lang. So yung check to 4n gali guys. So is this the difference of square? So we have ang 9, ang 81 pwede siya ma-factor as 9. Y raised to 2n para sa ating equation. So we have 2. So we have 2n. So multiply ta lang. So 2n squared. So that means 2n plus 2n. So kung squared ta siya, wala ni naka-multiply guys, amo ning confuse ko gali. Wala siya naka-multiply, so naka-exponent siya. So we have 2n plus 2n. So para sa aton nga so both silingon kaduwa ta i-multiply ang aton nga 2n. So ang aton nga y raised to 2n. So y raised to 2n times y raised to 2n. So i-add na lang tayo ng exponent. That's why we have y raised to 4n. So where did this come from? So halin diri sa original naton nga o sa sininga equation. So based on the concept of the rules of exponent. So the difference of factor or difference of square naton or square naton will be okay, so since perfect square man siya, both silingon, we have conjugate pairs. So we have 9 para sa first nga term, 9 man sa first nga term sa second nga factor. So we have y plus 2n sa next, y plus 2n sa next nga term. And then separated lang sila by plus kag minus. Okay, so base may mga concern da or may mga question, pwede gid maka-interact. Kung medyo may natalangan kita. So pwede natin i-check by foiling. So pwede ta na siya ma-check ang aton nga equation by FOIL method kung gusto pa natin i-check. If we would like to find the factors of certain polynomials, ang pinagiginahimo naton based on the intermediate kag basic algebra nga concept sa aton sang junior high ta, ginahimo naton is dividing the polynomials. Gina-divide naton. So first nga kinahanglan naton i-discuss is when we are given a polynomial kag kinahanglan naton mag-divide by a monomial. So ang ginahimo naton is isa-isahon ta siya, split the polynomial up into a fraction of its term. Medyo hapos-hapos lang ni kung amo ni ang given sa aton. Monomial ang aton nga denominator. So what we will be doing, so separate siya, isa-isahon naton, divide. So we have isa-isa ta, we split the polynomial divided by your divisor which is equal to 6x. So now reduce each fraction. Pwede ta ma-reduce ang ating fraction. We have 18x to the fourth all over 6x. We have also negative 24x cubed all over 6x. We have minus 12x all over 6x. So isa-isahon ta. This one, so pwede ta ma-divide, ma-cancel ta ang x to the fourth kag x, mabili na lang x cubed. 18 divided 6 will be equal to 3. Next, 24 divided 6 will be equal to 4. X cubed divided by x will be equal to x squared. Next, 6 divided by 6 will be equal to 1. X squared divided by x will be equal to x. Then we have 12x divided by 6x will be equal to, so 12 divided by 2 will be equal to, 12 divided by 6 I mean will be equal to 2. X divided by x, makansel na lang diretso. So we have 2 na lang ang mabilin. That means aton answer will be 3x cubed. So minus 4x squared plus x minus 2. That is the reduced naton nga fraction. Next, we have long divisions of polynomials. So, if the divisor has more than one term, perform long division. So, perform long division. So, diplastar ko dere, nga daw parehas lang siya sa ginahimo naton sang basic naton nga division sang elementary pa lang ta. So you do the same step with polynomials as with integers. Let's do two problems, one with integers and another one with a polynomial. So himuon ta, same lang Japon nga step. So we have first para sa sini basic natin nga division, ginahimo natin, gina-divide naman lang first term. 6 divided by 3, then perform na din ang operation. So same with the concept of polynomials, we have x squared divided by x. X squared divided by x will be equal to x. So x times x will be equal to, okay, so multiply ta na, x times x, I mean, so x times x will be equal to x squared. Then multiply man, we have x times negative 3 will be equal to negative 3x. So negative 3x. So we have, so next, minus ta. So minus. So sa original naton nga ginahimo, gina-minus taman gid. So still the same, minus taman. So we have ma-change. So since ma-minus kita, minus x squared, ma-change niya ang sign ng second term. So we have kag ang next ka mga terms, minus 3x. So imbis nga minus, may mo siya positive. So we'll have, add dayon. So x squared minus x squared. So we have next 8x plus 3x. So 8x plus 3x will be equal to positive 11x. And then perform the same operations na ginhimo naton kagina. 11x divided by x will be equal to, okay, so ang before tagali mag-divide, so pwede pa ta ka-bring down, so kay may bilin pa ta nga term diri. So 11x minus 5 and then perform na sang operation. 11x divided by x will be equal to positive 11. Positive 11 times x, so multiply naton, we have 11x minus 33. And then, so subtract kita, so we have to change the sign. So may mo siya, 11x, then ma-change ang sign, we have 28 as aton nga remainder. So kung i-plus star to siya in the insaktong form, so we have to add remainder here, and 28, so amonat na remainder, plus kung ano di aton nga divisor, divided by x minus 3. So amo ni subong aton nga answer for the division. So we found the answer to the problem x squared plus 8x minus 5 divided by x minus 3, or the problem written another way. So pwede nga divide nga sign, or amo ni yung itsura. Okay, we have another dere. Given any of terms are missing, pwede nga given as aton nga equation. So paano siya natin isulat sa aton nga long division? So we have y squared plus 8 all over y plus 2. So take note, wala kita linear term. So dapat butangan ta lang siya as 0. So we have y squared plus 0y plus 8, and we have y plus 2 as atong nga divisor. So write out with the long division including 0y for the missing term. So we have, so by division, we have y squared divided by y will be equal to y. So multiply to that, and we have y squared plus 2y. So y times y, we have y squared, y times 2, we have 2y. Then perform the subtraction. So ma-change na ang sign. Negative y squared, negative 2y. So we have then add ion. We have makancel ni then mabilin we have negative 2y. Bring down sa next nga term which is equal to positive 8 and then perform liwat ang same nga process. We will come up with the answer negative 2. So multiplying again, we will have negative 2y minus 4. And then aton nga remainder will be, so ma-change the sign. So we have 8 plus 4 will be equal to 12. So aton answer, i-add ta di aton nga remainder 12 all over y plus 2. So kung ang ginapangita lang sa imo is answer lang, so amo ni, but if included ang remainder, so amo ni ang answer natin. Okay, so another nga pwede natin himuon, shortcut for long division is to perform the synthetic division. Wherein, so dapat remember lang atong ginagamit is x minus k. So both silingon, so divide ta lang siya, i-change ta lang ang sign sa aton nga divisor. So since given kita, so x plus 3, so equate ta lang na by 0. X plus 3 is equal to 0, so x is equal to negative 3. So, ang muna dayon natin nga, divisor 3. We have negative 3. Next, list all the coefficient natin. So, tanan-tanan tanga coefficient, so copy ta lang. So, we have 1. So, we have 1, 6, 8 kag negative 2. So, ang muna subang natin nga, coefficients. Next, perform na natin. Bring first the number down below the line. So, we have 1. So, papanaog ta lang. 1. Next, multiply this and put answers above the line. So we have 1. 1 times negative 3, that will be negative 3. Then we have to add 6 plus negative 3 will be equal to 3. Then still the same multiply. So we have 3 times negative 3 is negative 9. Then we have to add. So 8 plus negative 9 is negative 1. Then we have negative 1 times negative 3 will be positive 3. Then add negative 2 plus 3 will be equal to 1. So we have this one will be aton nga remainder. And then para sa aton nga answer, so put variables back. So mabuhin ng ta isa ka term or isa ka exponent. So imbis x cubed, so mabutang ta x squared, then x, then constant na. So mabuhin ta isa ka exponent. Imbis x cubed ta masugod, x squared na ta masugod. X squared, x, then constant. So this will be the remainder naton 1. So the answer is x squared plus 3x minus 1 plus 1 all over x plus 3. Okay, so aton nga divisor. So any questions or clarification before tadanay magpadayon? Kasi may mga question or clarification. Okay, let's try another synthetic division. Given sang equation nga x to the fourth minus 4x squared plus 6 all over x minus 4. So we are given raised to the power of 4. But take note, meron kita missing a term. Wala kita x cubed, wala man kita linear term. So, kung wala na, substitutean ta lang by 0. So, we have, so ang aton nga divisor will be, so equate na ni sa 0, x minus 4 is equal to 0. So, x is equal to positive 4. So, we have 4. Then, kapit ang aton nga, butangan ta lang aton mga coefficient. So, we have x to the 4. So, x to the 4 naton is 1, x cubed naton wala sa butangan ta 0, x squared naton negative 4. So, ang x lang nga value or linear term will be wala siya sa butangan ta lang 0. Kapit ang constant term which is equal to 6 and perform the synthetic division. So, for synthetic division, we have, papanaog tala ang 1 una. So, we have 1. Then multiply, 1 times 4 will be positive 4. Add dayon, we have 4. 4 times 4 will be 16. Then add dayon, we have positive 12. 12 times 4 will be equal to 48. Then papanaog or add that naton, we have 48. 48 times 4 will be equal to 192. Then add, we have 198. So this means aton answer will be this one. Aton nga remainder aton answer binan ta lang by another nga by 1 binan to 1 ang ating exponent. So we have start with x cubed. So x cubed, x squared, x. So x cubed, x squared, x. Then this will be aton nga final answer. X cubed plus 4x squared plus 12x plus 48 plus 198 all over x minus 4. Okay, so that's it para sa aton nga synthetic division. Let's try a problem where we factor the polynomial completely given one of its factors. So, subong ma-factor na kita. So, paano siya natin himuon? So, factor x plus 2 ay factor natin nga for example, identify ta ang x plus 2 as factor of this certain equation. You want to divide the factor into the polynomial. So set divisor is equal to 0 and solve for the first number. So we have negative 2. So list ng tanan niya coefficient sa kumplito man, so wala tas ang i-equate or equal to 0. So we have 4, we have 8, we have negative 25, and we have negative 50. And perform the synthetic division. So for we have negative 8, we have, so multiply, so we have, kung i-add natin 8 plus negative 8 will be 0, multiply, we have 0 times negative 2 is equal to 0, so add natin will be equal to negative 25, multiply will be equal to positive 50, so that will be equal to, kung i-add ta will be equal to 0. Pag ang ating remainder 3 will be equal to 0, that means that is a factor of a certain equation. So, kung ang remainder, 0. Put variables back in 1x. Put variables back in. 1x was divided out in process. So, first number is 1 less than the original number. So, para sa ginhimo natin, bihinan ta lang. So, we have, in this x cubed, ma-start kita by x squared. So, we have 4x squared plus 0x minus 25. So, ang nabili na lang, so we have, atong divisor will be x plus 2. So, amo ni aton capital ang una nga factor x plus 2 and we have 4x squared minus 25. Okay? So, check ta lang. So, the second factor is a difference of square. So, ari, pwede ta pa siya ma-factor liwat kay difference of square siya. That means perfect square ang 4x squared, perfect square man ang 25. So, we have, this will be 2x, this will be 5, separated by plus minus kay conjugate pair sila. 4x, 2x plus 5, 2x minus 5. So this one, amo na niya ato nga complete factor of the polynomial. X plus 2, 2x plus 5, 2x minus 5. So we have real zeros of polynomial functions. So kagina, on the concept we presented, nakita naton ang remainder naton. So by using the long method kag synthetic division, pwede naton i-identify ang remainder. But take note also of the concept of remainder theorem. Base medyo nalipatan na ning concept sa aton nga algebra nga class. So if given kita a polynomial function of x, kag ma-divide ka by any term x minus c, so ang aton nga remainder is equal to f of c. Ano sir? So paano na siya sir? So himuon mo lang is to, for example, given ka a certain function. So kag ipa-divide sa imo by synthetic division, for example, makita naton aton nga remainder diri will be equal to negative 33. So for example, given ma-divide ka dapat by x plus 2. So the root of x plus 2. So amo na ginhimo naton. So by synthetic division, and we come up with an answer. For example, nga negative 33 kung gin-divide ta na ang aton nga remainder. So amo na aton nga remainder nga makuha. So himuon mo lang by remainder theorem, medyo masapos compared to synthetic division kag long method. Divide, multiply, I mean substitute ka lang values. So, if ang ipa-divide sa aton is x plus 2, okay, so amo niya, for example, ang x plus 2, i-check mo kung root siya or hindi. So, himuon mo lang. So, x plus 2, so find ang this will be equal to x. Equate mo lang man sa 0. So, x plus 2 is equal to 0, then x is equal to negative 2. So, i-check ta by substituting negative 2 sa aton nga equation. So, negative 2, so substitute ta sa aton equation. So, f negative 2, so what's siningon, substitutean mong tanan nga x by negative 2. So, ari na, nag-substitute ka values nga negative 2 sa aton equation. So, I come up with an answer nga negative 33, which is the same sa aton nako ang answer using the synthetic division. So, amo na aton nga remainder, negative 33. Okay? So, amo lang managali, sir. Hapos na managali. So, concept of remainder theorem by purely substitution of the root of your equation. So the remainder we get in synthetic division will be the same with the answer we get if we put negative 2 and the certain function. Next one, factor theorem. So, ang aton nga factor theorem, simple lang man natin yung gina-emphasize. So, kung given kita a certain function, and then para makuha natin ang aton nga, para ma-check natin ng factor gid sa of a certain equation, dapat f of c kung or ang aton nga function, kung i-substitute naton, dapat aton answer will be equal to 0. So kung i-substitute na nga value, dapat imo answer will be equal to 0. So that means that function of c will be equal to 0. So kung i-substitute mo ang imo value sa function, imo answer for example nakuha is 0. Then that means nga ina nga given nga function is a factor sa kina-factor nato yung equation. Or else, given kita factor, then dapat ang imong nga function of c will be equal to 0. Okay, so paano na, sir? So, for example, identify natin kung ang x plus 3 is a factor of certain equation, negative 4x cubed plus 5x squared plus 8. So, we have to identify kung factor ni siya or complete factor. So, what we have to do, so performing, for example, synthetic division, so we find out nga we have, so we change mo lang man ang sign dere, so we have negative 3. So, by synthetic division, we come up with a remainder nga 161. So, both silingon, it's not a factor of the equation. So, pwede ito siya ma-check by synthetic division, but ang pinakahapos gid is by remainder theorem. Substitute mo lang diretso. So, we have f of negative 3. So, we come up with the same answer, which is 161. So, both siningon, kay hindi 0 aton answer, it is not a factor. Our goal in this section is to learn how we can factor higher degree polynomials. For example, we want to factor x to the fourth plus x cubed minus 3x squared minus x plus 2. So we could randomly try some factors and use synthetic division. So we know by the factor theorem that if the remainder is 0, then pwede kita maka-factor. So pwede ito daw makapag gusto lang try ta lang kundi hindi daw makahatag 0 sa ating answer. So we might be trying things all day and not hit a factor. So in this section, we'll try to learn some techniques to help us narrow down the things to try. So this is through Descartes' rule. So the first thing is called the Descartes rule of signs. So it is named after Rene Descartes. So or Descartes sa iba na, sa iba nga mga pagbasa Rene Descartes. So medyo familiar sa aton si Rene Descartes because of the concept of Cartesian coordinate system. Nag-introduce sa aton sa basic concept of algebra naton sa first year naton sa junior high school. We have Rene Descartes or Rene Descartes. So Descartes' rule of sign. So we have let f denote a polynomial function written in a standard form. The number of positive real zeros of either of a function either equals the number of signs of changes of function of x or else equals that number less than an even integer. So the number of negative real zeros of f either equals the number of sign changes of f negative x or else equals that number or less than an even integer. So medyo gamo pa sir. Okay. So ano ko nang ginhambal ni Descartes? So tanaw ta lang kung kapila nag-change ang sign. So we have halin dari positive kag positive wala nag-change. Positive kag negative. So positive kag negative we have first nga change. Negative kag negative wala nag-change. Negative kag positive we have second change. So we have a second change. But silingon this one we have duwa ka change. That means there are two sign changes. So this means there could be two or positive real zeros. So we have duwa ka change either 2 ka 0 nga positive or we have buhin tabay even number. So we have 2 minus 2 pwede nga mangin 0 or wala kita positive real numbers naton nga polynomial. So hindi certain sir how nga 2 gid or 0. So i-check ta na siya karon makita ta na siya sa aton nga mga examples. Next, is lanta by negative ang aton nga function. So negative x sa tanan nga x. So we come up with an answer x to the fourth minus x cubed minus 3x squared plus x plus 2. Nakita ta, we have first nga change. So wala siya nag-change. We have another change. So but silingon, we have duwa man ka change dere for the negative value. So but silingon, either we have 2 a negative real nga factor or 0 ma-minus 2 man kita nga real nga factor sa atong polynomial. So check ta by an example kung anong bot silingon sina. Bot silingon sini nga rule ni Descartes. Determine how many positive and how many negative real zeros the polynomial may have. So we are given negative 3x to the fifth plus 4x to the fourth plus 2. So start with the first one. May ara kita first nga change. So we have 1 and we have no more na nag-proceed nga changes sa aton nga sign. So both silingon, there is one sign change. So both silingon, may ara lang ta 1 positive real, 0. So 1 positive real, 0. So 1 positive real, 0. So hindi naman ta pwede maka-minus even number pa kay 1 na siya daan. 1 minus 2 man negative na nakaroon. So both silingon 1 lang gid ang aton nga positive real nga factor. So next, substitute ta by negative sa aton nga x. So we will come up with 3x to the fifth plus 4x to the fourth plus 2. So this time, wala kita sang change nga nakita. That means wala kita sang negative real 0. Take note, counting the multiplicities and complex zeros, the total number of zeros will be the same as the degree of polynomial. So dapat, kung pila di dapat aton nga exponent, amuna dapat aton factor, amuna dapat aton zeros of polynomial. So based on the rule of Descartes, so we have isa lang ka positive, wala ta negative. Wala ta, again, isa lang ka positive, wala ta negative. That means, ang iban gali naton nga factor is imaginary. Dali na naton masulod ang imaginary factors. So Descartes' rule say 1 positive, no negative, 0. So there must be apat ka complex factor. So 1 ka positive, wala negative. So we have both silingon apat. Ang apat nga nabilin nga sign is a complex number. So back to our original polynomial na gusto i-factor, we are given x to the fourth, x cubed, negative 3x squared minus x plus 2. We need to try a lot of positive or negative numbers until we found out that had zero remainder. To help, we have the rational zeros theorem. So we have rational zeros theorem. So check tani by an example ang rational zeros theorem. What this tells us is that we can get a list of possible rational zeros that might work by taking factor of a constant divided by the factor of the leading coefficient. So halin sa constant naton, ano naton constant? So we have factor of a constant. Ano factors ng constant naton? Factors ng 2. So we have either 1 or 2. Next, factors ng aton leading coefficient. Factors ng aton leading coefficient is 1. Anong factors ng 1? So we have 1 or 1 lang gid. So amo lang muna aton nga factor 1 or 1. So we have divide na lang aton nga sign. So we have this one, take note nga pwede positive or negative. So we have positive negative 1 or positive negative 1, positive negative 2, ag positive negative 1 sa ating exponent. So we will have, so list of possible things to try would be, so plus minus 1 or plus minus 2. So we have the possibilities ng amo ng root sa ating equation. So let's try. So since na-narrow down ta na nga either amo lang yung ating roots, so pwede ta matry ang positive 1. So let's try 1. So okay, pinakahapos. So, atong digin himo synthetic division, so pwede man tayo Japon maka remainder theorem kung gusto natin. So we have 1. So we come up with an answer or remainder nga 0. So for the 1, so atong remainder is equal to 0. So this means this one is a factor sa aton nga equation. Next, we come up with, kung i-simplify ito siya, so take note, 1 diri, so kung ihimuon mo na siya nga function, dapat ma-change na ang sign, that will be x minus 1. And we will have x cubed ma-minus, tas isa lang ka degree, x cubed, 2x squared, minus x minus 2. Okay, we found positive real 0, so the Descartes rule tells us there is another one nga positive. So, may isa pa ta ka positive. Okay, kay may duwa ta ka ginaka-change. So, both silingon, may isa pa ta ka positive. So, we have to try. Let's try 1 again. Basi pwede pa lang. So, by factored version. So, diri na lang ta ma-start by 1, 2, negative 1, negative 2. So, try ta siya. Then, we come up with so we have, kung i-try natin liwat ang another one, diri na sa nakuha natin nga factor. So we come up with a remainder nga 0 man Japon. So both silingon, factor man Japon ang x minus 1. So we have, next na lang, himuon natin is to factor na sang x squared plus 3x plus 2. Pwede na siya natin completely ma-factor. So we have x plus 2, x plus 1. So we have, nakita natin, kagina ang x minus 1, kaduwa siya natin gin-divide. So we have x minus 1 squared, then base natin nga previous nga factoring, we have x plus 2 kag x plus 1. So we have x plus 2, x plus 1. So in this factored form, okay, we ended with having duwa ka positive. So positive zeros, 1 and 1, duwa ka negative zeros, negative 2 kag negative 1. So, insakto man ta by the concept of Descartes' rule of sign. So, duwa ka positive nga roots and duwa ka negative nga roots. In this factored form, so makita na nato ang aton nga mga intercept nga pwede naton magamit by the concept using the concept nga introduce naton kagina with the behavior of graphs. So pwede na naton ma-graph gamit ang aton nga form or ang aton nga mga intercepts. Let's try another one from starts to finish using the theorems and rules to help us. So using the rational zero, so medyo i-identify naton ang aton nga factors. So first, starting with the factors ang aton nga constant. Factors ang aton nga constant is 9. So we have anong pwedeng makamultiply sa 9. So pwede 1 times 9, may mo siya 9, or pwede 3 times 3. That means ang aton nga factor is 1, 3 kag 9. But we have to take note, positive kag negative, kinahanglan naton i-consider. Next one, for the coefficient naton. Paano naton i-factor? We have 1 kag 2. So, but take note, may pwede man nga positive negative na siya. So, nga importanteng nga concept because this one hindi ni siya madiretso sa calculator. So, kung raised to the fourth na, wala na siya sa calculator, hindi na siya pwede ma-factor. So possible rational zeros are all possible combinations Okay, so possible rational zeros are all possible combinations ng aton nga factor of your numerator kag denominator. So we have either positive negative 1, positive negative 1 half, positive negative 3, positive negative 3 halves, and then positive negative, so 9 all over 2. So, amo na lang ni subong. Imbis na mo damo ka possibility of factors, dali ka na lang subong ma-focus nga mga roots nimo of your equations. So, amo na subong pwede natin i-substitute para for the remainder theorem or for the division, long division or synthetic division. So start ta danay, tan-awon ta kung pila ka positive, pila ka negative sa ating equation gamit ang rule of Descartes. So wala kita sang kung i-inspect naton, wala kita nag-change ang aton nga sign. But silingon, it stays positive all throughout. So no sign changes. So wala kita sang positive real nga wala kita sang positive nga roots. So that means we just ruled out half sa ating mga choices. That means wala ka na positive. That means negative na lang. Okay, imagine nadula natin ang tanan nga positive. So that means medyo nagkapos-apos ang aton nga choices of the roots because of the help of Descartes' rule. Next. Start kita with your negative or identify natin ang negative nga mga factor kung pila kabilog by following the rule of Descartes. So we have 2x to the fourth minus 13x cubed kung i-substitutan ta na by negative x plus 29x squared minus 27x plus 9. So makita naton we have first nga change, second nga change, third nga change, fourth nga change. So ang ginatanaw din natin nga change is aring nga sign, positive to negative, negative to positive, positive to negative, negative to positive. So may ara kita apat ka change. That means 4 sign changes. Subot silingon either sa aton nga negative, either may ara kita apat ka negative, either duwa ka negative, or either 0 ka negative. So pwede kita maka-minus by even number. So 4 minus 2, so pwede either dara lang aton nga negative real zeros. So let's try. Una, let's try by negative 1. Okay? By negative 1, so we come up with a 0 nga remainder. Subot silingon, this is a factor. So we found this is a factor. So we have x plus 1 is a factor. Okay, again, change ang sign ha. X plus 1 is a factor. Next, ang nabili natin nga term, pangitaan taliwat factor. So we have, ano pang pwede natin ma-divide? Let's try again, negative 1. So, if we try again negative 1, we come up with another 0. So, another 0. So, what's siningon sa ating remainder, what's siningon, x plus 1 is again a factor. Next, we have 2x squared plus 9x plus 9. So, so pwede ka di ka perform pangita ka di value or pwede ka di diretsyo na lang, pwede ito siya ma-factor. So, we have 2x plus 3 kag x plus 3. So, pwede ito na lang siya complete factor. So, 2x plus 3 kag x plus 3. Ang naka-squared na lang, pwede na siya madiretso sa calculator kung gusto niyo i-factor gamit ang calculator. So, 2x plus 3 and x plus 3. That means we have, pwede tadi dugang 2x plus 3 and x plus 3. Negative 3 halves and negative 3. Okay, so pwede ito na siya magamit sa aton nga graph. So we have x plus 1, so we have x minus 1. There is x minus 1. We have x is equal to 3 halves. So this one, negative 3 halves. And we have negative 3. So based on the graph natin, sa x plus 1 matouch lang siya. Sa negative 3 halves macross, sa negative 3 macross. So we have this graph sa aton nga function. Wait lang. Okay, so let's proceed with the complex zeros of a polynomial. So, complex zeros of a polynomial could result from one of two types of factors. Number one, x squared plus 4 is equals to 0. Wherein, makuha na ito ng atong factor, x squared is equal to negative 4. Or we have plus minus 2i. Kung nagkuha kita sang square root sang negative number, dara masulod ang complex naton nga roots. Next, another factor is x squared plus 2x plus 5. So we have, using the quadratic formula, we could come up with an answer ng negative 1 plus 2i. Or pwede nyo magamit ang concept na gin-introduce ko last time and the first nato nga session kung paano kita nag-factor atong ginpahapos nato nga factoring nga equation. So notice that with either types, the complex zeros come in conjugate pair. So dapat positive, negative dapat ang imong roots for the complex number. So if asked to find a polynomial that has zeros 2 and 1 minus 3i. So for example, given sa aton nga pangitaon mo ang polynomial ng iyang roots include 2 and 1 minus 3i. You would know yang another pagid nga factor niya is 1 plus 3i. So kay dapat conjugate sila. Okay? We have, if x is equals to the 0, then x minus the 0 is a factored form. So we have given ta 2 kuno as root, subot silingon, kung i-substitute mo na siya nga may ara na siya x, subot silingon, ma-change ka lang sign, x minus 2, so we have x minus, so ari butang ta 1 minus 3i, then x minus, so ari butang ta 1 plus 3i. Okay? Then, pwede tayo i-distribute ang ating nga sign. We have x minus 1 plus 3i, x minus 1 minus 3i. Multiply the last two terms together. So, all natin nga terms should disappear when simplified. So, we have x minus 2 Then himuon naton is distribute. So we have x times x, we have x squared. X times negative 1, we have negative x. X times negative 3i will be negative 3xi minus, so we have negative 1 times x, negative x. Negative 1 times negative 1 is positive 1. Negative 1 times negative 3i is positive 3i. 3i times x will be 3xi. 3 times negative 1, 3i times negative 1 will be negative 3i minus 9i squared para sa aton nga 3i times negative 3i. Then we have, so pwede ta cancel ng mga terms, negative 3 kag positive 3xi makancel, 3i kag negative 3i makancel man. We have a simplified answer. Okay? Take note nga ang I squared, so wait. Take note nga ang imo nga I or ang aton nga imaginary number I is equal to square root of negative 1. So both silingon kung squared tani ang I squared squared. So I squared is equal to, so makancel, mabilin is negative 1. So ang I squared is equal to negative 1. So pwede ito lang siya substitutan sa negative 1. We will come up with an answer. So this one, may mo siya negative 9 times negative 1, may mo siya positive 9. So we have x minus 2, we have x squared, we have negative x plus negative x is negative 2x plus 1 plus 9 is equal to positive 10. So that's it para sa aton nga array sa aton nga complex number. So in order to completely expand this one, multiply ta na sila, we will come up with an answer x cubed minus 14x squared plus 14x minus 20. And that's it para sa aton nga factored form of a complex number. So we will not dwell into a deeper pagiging concept of factoring, but we have, at least I introduced the concept of complex zeros into this discussion. So any concern before we end up this discussion? So any question? Any question for Delane, Jefford, Jaina, Hannah, kag Edmar before kita mag-end? Or clarification? So medyo jutay-jutay, kamusta buong kay damo-damo, no? Damo ko din nakita nga nag-enroll sa subong gid nga adlaw. Okay, thank you, good Edmar. So for the link question, to my question, Jaina. Okay, thank you, Geda. So, this is it na para sa sininga discussion. So, kung gusto niyo video or discussion video, pwede gid maka-message akon. So, thank you, Ana. So, pwede lang ka-message akon. I will be sending lang link sa YouTube para sa inyo. So, pwede lang. And PDF man kung gusto niyo PDF. So, thank you sa pag-join subong. So, thank you, Gid, sa pag-join for Delin, Jaina, Hannah, Edmar, at Jefford. So, thank you. Kaya wala naman question, pwede na taka-leave sa kola. Thank you, Gid. Thank you. Thank you, Gid.